it's going to compile from yes.o by the things. Yeah. Okay, great studio. Is the screen size all right? I mean, font size.
Yeah.
And I think my build here is done, and actually it's errored. So now I run it again without the parallel flux to see what the error actually was. Did my VM boot?
Sergey, when you get a chance, can you try the performance settings, best performance, when you
Sure.
get a
Let
chance?
me. Performance settings. Oh, hold on, this doesn't matter anymore. I'm over here, so I should do this. Performance settings here, and then best performance here. Okay, is this any better? Anyone?
It's probably better. It just audio quality for me is really bad. So the recording's going to be really bad because the audio quality is really bad.
Yeah, you
I've just
somewhat choppy as well.
OBS to enable recording, but I'm not sure that my OBS configuration is the best.
It's probably as good as we're going to get it. So that's okay. We'll continue. Thanks, Sergey.
Maybe I should try to speak slower and clearer, if that's possible. Please tell me if you need me to repeat anything or whatever.
That
And
does
again,
help me, but I think everyone else can hear you better than I can.
also, yeah, please ask questions. Like, I really don't want to be talking into a void. All right, I want to be talking to you guys. So please do. All right, we got a builder here. Let's see. This is in IO. IO.fg open, and that doesn't even seem to be a file. How is that? Libio. And 54 use mmap. It is usable, except for ghave mmap. ghave mmap, that does ring a bell. This gets set depending on whether or not we have exact page size. And there was a commit that, well, I added a commit that dropped the check for exact page size because I don't want it defined on AH64. And then I had a discussion with one of the glibc maintainers, and it never really got anywhere. And Samuel, for some reason, he pushed my commit already, and we both told him that we didn't expect the commit to get pushed before we come to an agreement. And he said he was sorry and reverted it. So now that I've rebased in the latest master, this has the revert in it. So that's why I'm getting this error. So let's actually grab the commits exec page size, something like this. Yeah. So this is the revert, and we wanna let's just cherry pick the commit again like this. And build again. I'm not sure let's do the full thing. Right. So let's get back to writing some translator. Let's just start by writing a simple hello world without any TrueFS or anything. Hello world, /n. Let's see if I can build this. So again, let me source my depth cross HURD. I'm building for whatever this is, I686 GNU. If I do make, this is going to try to use CC, which in my case is going to be host GCC, which I don't want. And also let's add the clear target here. RM, force, and yes.o, and yes. Doesn't recognize clean, not clear. Right. So what I want to do is set CC to this. This is going to link compile using my cross compiler for the HURD, and try to link against TrueFS, and that's not going to work because we haven't defined any of the functions, which is fine. So let's disable TrueFS from the link for now. And it links, and we should have a file called yes, which is an executable for the HURD. So now we should be able to take it from here and copy it over to my HURD VM, just like that. And we SSH into it, and we run it. Temp, yes, and it says hello world. And this was, as you've seen, just cross-compiled from my host running in Linux and not the HURD. Does that make sense so far? This is just the basic setup for compiling code.
My question for you is the current terminal we're looking at, Sergey at HURD, is that Linux or is that the HURD?
It was Linux up until I typed SSH HURD. Then it became the HURD. And you can, in fact, like look at the color of the header here. If it's Magneto, whatever color is this, you know, it's an SSH session into, in this case, into a HURD VM. And when it's white like this, it's my host.
So you're not really running Debian then, you're just running maybe Flavio Cruz's cross-compilation scripts?
My host here, this is actually a Fedora system. Not that it matters, it should work on anything, but this is a Fedora. And this guess here, this is Debian in a code. Let's actually open two separate.
Pretty cool.
Let's like this. Let's open two separate tabs. Let's not confuse you. Should have my agent here. Yeah, so this is going to be the HURD tab, and this is going to be my host. Is this any clear? Okay, so let's. I wonder if I would make file here. Yeah, it's going to reset the scale. So let's try to do something more interesting. So first thing translator usually does is it gets its bootstrap port to check if it's a translator at all. So let's do that. RTR, and also let's define GNU source code sets. That's nothing really going to work without that. So define GNU source to 1. Let's include mark, I guess. Mark each. So we do this. Task get bootstrap port. Mark task self. Bootstrap. And that that should have worked. If it didn't, it would give us the error, which we don't expect. So let's do assert p error backtrace error. So if this doesn't return success, this will basically fail the whole process with a descriptive error message. And then let's see if the bootstrap port that we got is in fact the port. So if it's null, that would mean that the task was started just normally. So tasks started on the HURD in a normal way like this. Okay, this is the task. It doesn't get a bootstrap port. It's null. But tasks started as a translator, they do. And it is that bootstrap port that they use to communicate to their parent translator before we started them. So we get an ours, and we're gonna compare it against null. If it is null, we're gonna print an error message saying must be started as a translator. You must have seen this 1,000 times when trying to run any other translator. Like this, right? You can do say HURD is 2fs. Again, maybe not this. How about HURD random? And it would say must be started as a translator. That's what we're doing here. Let's also include error h with this.
Is assert underscore PR backtrace, the assert PR backtrace, is that somewhat of a new function?
No, that has been in the HURD for like 10 years. It's not new. So glibc provides assert the error like this without the backtrace part. This you can use on bare glibc. So basically in any HURD or Linux program, as long as you define this in a source. Assert pair backtrace and just assert backtrace are HURD specific. You get them from lib should be in libc, I believe, which is a hilarious name for a library. Basically, all of the HURD other libraries use lib should be in libc, so we're safe using this. Since we're going to link to libtfs. What this is going to do is it's going to see if error is 0, and if it is, nothing else. If it isn't, it will print an error message corresponding to this error code, and then the backtrace of the, well, in this case, it's just going to be mains, not that interesting. But yeah, whatever backtrace you're on. And then it will abort the whole process, so you won't proceed, just like an assertion. Right, the next thing we do is we contact our parent, and this is going to be has startup, I believe. And let's look for the signature in fact. So let's open and dev cross-HURD source HURD libtrifs h, and I need to increase the scale to 130 again. Right? Startup like this. Okay, so it takes the bootstrap port, and this is what we got here. Then some flags which we don't care about. So let's specify 0. And then 4 pointers to port classes and buckets, which we don't care about either. So let's pass 4 nulls. And finally, it's gonna set a control port. So let's declare struct trifs control. This it's called control fully. Okay, let's spell it out. Pointer, and we're gonna pass the pointer to that into here. And again, let's use if that failed, let's just print an error message. Failed startup. Also, we should take a peek at. Okay, that's done. Let's switch. It seems to have worked. Yeah. So we should now have libc.so lying around here, which is armh64 dynamically linked. Cool. So let's now make install. And this is gonna throw an error, but let's see. Oh, it won't. Hold on. Maybe we should rebuild everything.
Sergey, have you ever tried using Vim or Emacs?
I Yeah, I tried using Vim. It's not my thing, certainly. I've been using Emacs for several years, and then I kind of got out of it. So now I'm mostly using either Nano on the command line or something more of a GUI editor like this GNOME text editor by Christian here. Yeah, it's not gonna install properly. I shouldn't have configured this. Yeah, let's rebuild it again. Yeah, I'm gonna remove everything. Dear build, configure, and you're not gonna pass prefix. I'm not gonna pass prefix. I'm gonna do this. Yeah, or even just pass user thing. Yes, let's rebuild it again with a different prefix. Okay, so what I wanted to do here is open the hello example, copy code from there. And it should be in trans hello. For hello utilities that works. This is what we want to do. This uses script ports to start running, and yeah, this is multi-threaded. We don't need that actually. Let's open the single-threaded version and copy from there. That's simpler. Basically, this would run the reports event loop, receiving incoming requests and replying to them. And actually, as the example shows, we should deallocate the bootstrap ports. Let's do that. And I like the example. We're going to check for the error code and do this. And we should include TrueFS. Include HURD TrueFS H. Also, let's include port H since we're using it here. Let's see if we can still build this. We can't, because it's called FSys, and this was called control, which is fine. Let's just replace it. Yeah, cool. So, first of all, this didn't link. Second of all, these are all missing. So let's fix both of those. Bring back TFS, and let's use lib should L lib should be in libc. That didn't find it because not L, but L should be in libc like this. Yeah, and we need L ports. Cool. So these are all missing references, and we have to define them in our program. So let's again borrow some code from hello.c. Please, please. This is pretty stupid. This is just to tell them through path which FS type to report as system as. That's going to be some miscellaneous type. And you can, in fact, see all of these values. Let me show you where. It should be HURD types like that. Okay, what? HURD types H. And increase the font size. reference type, these ones. This one is over the code. Yeah, you can basically pick whichever one you like, but most of them end up being first type MISC. It should be here somewhere. But there is first type X2FS, first type HTTP, whichever you want. FSID, we normally set this to your PID, so let's actually do that. FSID equals get PID. Let's drop initializer from here then. TrUFS allow open tells TrUFS how our device node should be allowed to open. In this case, only for reading. And this says the same thing. And the difference I don't quite understand the difference, so we could grab for it and see. It would be there, source, HURD, pass. Like that for this. And it's not used for anything. Cool. TrUFS support read is basically only used for checking things.
What is the command RG?
RG is read, not like that. Version, yeah, it's rip grep, which is a replacement for a typical Unix grep, written in Rust, and apparently much faster than the original, at least so they claim. And it is super nice to use. I use it whenever possible. You cannot use it on Rust.
Okay. That's cool.
On the HURD though, since it's written in Rust, and Rust and HURD exist, but it's not quite. So I would always struggle whenever I work on my Debian HURD system. I type in RG and I get command not found, and I have to type in grep-r instead. So that's annoying. But here, for one thing, it's faster. For another thing, it just has the same defaults. So if I just say rg something, it recursively searches the current directory for that. If I do like this, it will search the piped thing into it. Does things like highlighting and whatever, and you can filter by type. So let me show that in libc here. Rg a cut type C, and this will only search C code and not everything else. Okay, where did my history go? This -tc thingy would only search C code, and type H would only search the header files and not the actual code. So that's quite useful. Yeah, let's keep the build running. Yeah, so I don't quite understand what the it's not it. Yeah, what do these things do other than toggling asserts here and there? But let's declare them in a way that match the ways we allow to open our file. And let's try to build again. And get PID is not defined, which is explained because we haven't included uni SDH. Right? Okay, so it's better. And we have to declare, define at least these two functions. TrUFS go away is called when somebody asks our translator to go away with trans -g. Yeah, let's rename our control part to this. MTL. And we have nothing to do here really, we just exit. And we're done. And the other thing is TrUFS modifies stat, which defines how our node will look like, basically in stat 1 or less output. basically we have to, let's say 64 here, have to set ST mode and other things. Let's support a length of 0 for now. And this is what our users will see when they will try to start our node. So this should be enough to make it link. Cool. Let's copy it over to my HURD VM and see. Okay, temp, yes. Run it, and it says must be started as a translator, and this is this line right here, because it doesn't have a bootstrap port if you run it normally. So let's start with a translator. Temp yes is already taken. Temp dev yes, like this, and we should be able to start temp dev yes like this, and get whatever we wrote here, which is the size of 0, indeed, and the type is going to be a regular file with these access permissions. Yeah. Well, actually, this is probably broken because stat uses stat x, I think, with add no auto mount, and that was broken on glibc side. Don't read too much into this. This would probably remain the same if I said that it is like that. If okay, let's actually read the manual here. Main I know. Yeah, let's for instance say that it's a block device. Stat is still probably gonna report it as a regular file. Copy it over. Now let's say trans g temp dev yes, and this calls this, right? Truth has go away. Now program should have exited. And we should set the new translator again. And rerun stat. Oh no, it's been fixed. So it now says block special file. Cool. So does this make sense so far? We just basically
is it automatically compiling somehow?
What?
I didn't see you like run make or anything. Is it like compiling just automatically?
Right here. Maybe it was too fast. So let's make another change here.
Just quick.
Instead of block, let's say that it's a socket, right? I copy this over from here to here to the source code, and I save, and I go to this tab and I run make. Right? You see that?
Yep, I saw it.
And then I copy the resulting file over to my HURD VM, which is called HURD, and is of course available under that name. Oh, it's not available under that name because of the terrible MDNS responder, because I actually think I have it configured in my SSH config. HURD, yeah, okay, that's not actually using terrible MDNS responder, but it should be available as that too. So let's try get and it hosts Cargo local, and that doesn't work at all. Okay, you know why that doesn't work? That doesn't work because getend ends one being the one from crossHURD, which is the one that's built for the HURD. So let's do that in another tab that doesn't have that installed. That would work. Yeah, see? So it's also available.
You should also probably tell people about the terrible MDNS responder.
Right. Joshua has recently done a video on that. Basically, MDNS is a protocol designed originally by Apple, I believe, to enable devices to discover each other on a local network without any configuration. And it's called MDNS, which stands for Multicast DNS, since it's basically just regular DNS, but instead of any DNS servers or anything like that, basically devices just shout, just throw packets multicast packets into local network, and everybody else hears that. They can all see each other on any local network, and they like negotiate to use their host name at local as their domain name. And yeah, if you have, well, there are two parts, basically two sides to an MDNS transaction: the MDNS resolver and MDNS responder. Resolver being the thing that runs on your side, whichever side you're querying from. Yeah, whoever sends the query. And MDNS responder is the thing that runs on the other machine, the one that replies to your query. So on this host here, I should have, I think I have systemd resolve. No, like, I mean, I do have it, but it's configured to turn off MDNS. So I must have, I wish I knew how to pronounce this properly, Avahi. Yeah, so this should probably work then. Avahi resolve host name kernel local. Yeah. So this is an MDNS querier, shall I say, that's running on my GNU Linux machine right here. And on my Debian GNU HURD machine, the MDNS responder is the terrible MDNS responder written by me. It should say service terrible MDNS responder status. And it should say command found because it's sudo, which doesn't actually need. I should be able to do this as being, yeah, just to detect that it's running. I don't need to run sudo. So it is an extremely simple MDNS responder implementation, one that you should not use because it's too terrible, but actually it's not quite terrible. It seems to work okay. I've been using it myself. Well, I wrote it for myself. I'm not, it's not any sort of product. I've been, yeah, for this exact purpose. I just wanted my HURD VM to be pingable or reachable by its nice symbolic name instead of its raw IP address. Yeah, terrible MDNS responder, it's really simple. It's very basic. It doesn't do any of the advanced stuff. You wouldn't want to use it instead of, say, Avahi or systemd resolve D or Apple's MDNS responder, if those work for you. But if they don't, and on the HURD they don't, this seems to work okay. But you've been warned, it's terrible. Okay, so this, while we were talking, libc here seems to have compiled again. So if you do make install, it should complain because this time I had configured it to install into /user, which of course my user here shouldn't have the permission to write to. So I wonder why it takes this much time to get there. This is all just to figure out that it has nothing to compile. This is how much make takes. Yeah, exactly. It's trying to install into my host user, and it's not allowed to. So instead, let's say dest-dir equals prefix. Prefix is environment variable, which is this dev cross-held AR224. It should be able to install there. Right. So back to this. This function gets called whenever somebody queries our stat, such as with stat command, but also, for instance, with ls. But did I actually change this? Okay, this is now a socket, and we copied it over, and we tell the old one to go away, and we start a new one, and we start it, and we get it as a socket. Cool. And we should be able to do the same with ls. Yeah, it's a socket. And they both return 0 as a size. So that's what we've said, but we could say 1, 2, 3, 4, 5. Let's try that. Copy it over. And actually we can get rid of the old one and start the new one with a single command like this. And now it has a size. I close that. But we cannot read or write it. We can try, and we'll get the assertion that fails. Basically, what happened is it tried to read the file, and then we never implemented the function to read it, and then the translator panicked. This is what you see when that assert backtrace function fails. This is the backtrace. This is the assertion. So let's implement that. IO read. Let's just take this prototype from the header and copy it into our file. And tweak it a little. That goes here. And this goes here. And libc has installed, which is cute. For ID T, that's actually route ID. It's actually a pointer to this. So let's replace this ugly types with these nice types. This is going to be port ID called cred. This is fine. Data T is char star, and the rest are fine. Okay, so let's talk a little bit about this, I guess. What the hell is 3FS port ID? Because I saw you struggle with this. So basically, the way this works in Unix for now is that on a disk, on a file system, you have an inode, right? An inode is basically a node in the file system. And then you can open it, and you get what POSIX calls open file description. And this open file description stores things like how it was opened, basically for reason of writing, right? And the read or write offset, like where in the file you are now that you're reading it. And maybe some flags like whether or not you're doing this in a non-blocking manner. And then you have file descriptors in processes that refer to this file description. And you can have multiple open file descriptions referring to the same inode. They will all access the same file, but they will be accessing it at different positions, and possibly some for reading and some for writing. And then you can have multiple file descriptors which refer to the same open file description, and they will share the same offset and the same flags. And typically, the way you get multiple open file descriptions referring to the same inode is you just open the node multiple times. And the way you get multiple file descriptors that point to the same open file description is either use the dump syscall, or you just fork, which creates a second process that shares basically all the same file descriptors pointing to all the same open file description. So file descriptors are duplicated, but the file description, open file description, is shared. I hope that makes sense. And that's a generic Unix thing so far. It's not HURD specific. So in HURD, basically in the three HURD translator frameworks, these are represented, these concepts are represented by these structures. And actually, this doesn't make sense for 3FS specifically, because there is just a single node. I don't understand why this structure here exists at all. It shouldn't, because it is just a single node. But since it does exist, let's discuss it. So 3FS node, or in some more real examples, this is going to be like either NetFS node or DiskFS node. is a node on disk or imaginary node on the file system. And then you open it and you get one of these, what Alex calls open file description, the HURD calls per open. This basically points to the node. It should have, I'm not seeing this here actually, but it should have the offset. And it stores how it was opened, basically for reading or for writing. And then, like the server doesn't directly deal with file descriptors. Those are up to individual processes to track. What the server does care about is permissions, or basically identities, authentication. So the way this works in a more traditional Unix kernel, like the original one, the original Unix kernel, or Linux, or whatever, any BSD, macOS, and even in Serenity. The kernel is basically monolithic, and you can, in the kernel, whenever the user tries to do something with a file, you can basically just check which user ID the current process is running as, and check its permissions, right? And thus determine whether or not it should be allowed to do the operation, to access the file in some way. Not so in HURD, because it is a capability-based system. You don't know who's attempting an operation. All you know is what operation it is attempting to do. You cannot know who it was. So instead, the HURD tracks basically on the file system level. You can have multiple handles to the same per open, all authenticated with different credentials. And then whenever you want to change your user ID, either drop privileges when, for instance, you log in as a user, or raise privileges typically with user ID, you do what's called reauthentication. You create a new one of these, a new prot ID for a different user ID, and then you use that. So basically, you cannot know which user identity the current process is running at, but you as a server can know which prot ID it is accessing your per open through. And you have this user right here. This tells you which user is attempting the operation. I hope this makes sense. Please tell me if it doesn't, and if I should expand. Anyone? Okay, this is exactly what I told I didn't want to happen. I don't want to be speaking into a void. Please listen to me and ask me questions. Well, lie is not the word here. There is no file except for what you make it to be, right? You are the file system. You determine whether or not there are any files, or which files there are, and what types they are, right? You don't lie.
Sounds right. It sounds right.
No, really, it's not that there are some files and you present. It's not that you're lying. You're presenting the files. You can say that there are no, well, TrioFS presents a single file, but if you are using, for instance, MetaFS, you could say that there are no files at all, right? Well, except for the root node, I guess. Would that be lying? Like, same as, for instance, if you're chatting with someone, then you lie about a message. Well, no, you decide what to type in a message, right? Whatever you type gets sent. Yeah, the file type is just basically indication. Everything you do is basically indication. So you could like put one size here, and then upon reading, you would return a different thing. The user program would probably not expect that and get confused. But this is, yeah, mostly information. Whichever you want, you can put here. The goal should be to confuse the user program less, because they are typically not written for the HURD specific case, they're written for generic Unix, and they don't expect files to behave in a funny manner, right? They expect files to just be normal, regular files. So you should try to appear as normal as you can, but you can't put anything here. Right. So let's get back to this. You get this CRED, and this basically tells you who's accessing this file, what permission do they have. And this is really not important for a single file system like TFS, since if the file is already, or it has already been opened, it shouldn't really matter who's reading it now. This really matters when your file is a directory and you're trying to look something up relatively to it. And that's not the case for TFS, since it's okay. Dot and dot for directories. Those are basically regular entries. The file system should take care to implement them in the expected manner. The HURD file system frameworks do it for you. You shouldn't have to worry about that, unless you write in your own file system framework, like I might have done more than one time. But yeah, if you're using, well, again, TrioFS only implements a single file system node, like a device or file or something, which is actually quite a common case. A translator that implements a single node, which is why it makes sense to have a simple framework just for that case. But it's like its elder two brothers, libnetfs and libdiskfs, have to deal with a lot of this. And if you look at, this should be file lookup, I believe, or dir lookup, dirlookup.c. So this is dirlookup.c in netfs. That's the implementation. That's what it tells you. So you don't have to worry about this. But like it has this huge loop where it tries to find the next component of the name and resolve it against whatever. Yeah, I mean, it's large. And it should do the right thing for, okay, maybe it doesn't even handle dot and dot specially. Maybe your, where was that? Yeah, maybe your lookup method is supposed to handle it. But yeah, the correct answer to the question is that dot and dot, not just in HURD, in all of Unix, are basically regular file system entries, regular directory entries, with just those special semantics, but everything is expected to implement them correctly. And actually, I believe, in X2 and its derived file system formats, those are actually direct stored on a disk as file system entries. So they're not virtual, they're real file system entries actually really stored on a disk. How cool is that? I don't know. Cool is the right word. Okay, let's get back to this, but keep those questions coming, please. These are the reply ports and its type, which you don't care about, and we shouldn't have to care about unless we're writing an asynchronous implementation, which we're not. But if we did, we would do this. We would return mig, it's called mig no reply here, and then later on we would store these ports somewhere, and later on we would reply to these ports with a special reply message, and the client wouldn't be able to tell at all how we pulled this trick. To the client, it would look like we did a normal implementation. Yeah, so basically what this is, let me say a couple words about this. This is a function implementing the read support. It's not just any function. It's basically a Ming routine. So how that works? Well, the HURD, of course, is built on top of Mac. And Mac is a microkernel. And microkernels somehow are known for their IPC and RPC mechanisms, although technically they're not related. But somehow it always works out that way, that microkernels have a strong RPC mechanism on top of them. Mac is no exception. So Mac has this Mac IPC and Mac RPC mechanisms, and RPC is built on MIG. MIG stands for Mac Interface Generator, where you define routines in some domain-specific language. Let me show how it looks. We heard IO devs in this case. So IO read this here. This is a routine describing basically reading from any file it can be read from. On this mode off now. This is the file being read from. This is the return port, and this is the data that you get in reply. This is the offset that you read at, and this is the amount that you wanted to read. And what happens then is multiple servers, multiple translators, implement this RPC, and then libc contains, basically libc implements the Unix read function that you all know in terms on top of this RPC. So basically, whenever any program does read, simple classical Unix read, libc calls this routine as a client, and the request gets sent to some server, whatever server implements that file, and that server's implementation gets run, and it returns the data, and then the data gets returned from the Unix read call. Since we're encrypted directly here, let me actually show you how that's implemented. So it would be in HURD read, I think, or just fd read. The function is HURD fd read, and it calls IO read, which is the routine that we just saw. And this is the C client function for that routine. So it basically saves these arguments into a Mac message, sends the message, and then waits for a reply, and unpacks the reply back, in this case, 2 bytes or whatever. And then there is indeed stupid, so let's use find. Yeah, it's in scissors, of course. This here is the actual Unix C function implementation. It's called libc read, and then it's alias to just read. And it's called read no cancel. And read no cancel is, let's use find again. Okay, this is step no cancel. Yeah, this. So read no cancel calls read that we saw before. So that's the client side. That's what happens when a regular program that doesn't have to know anything about HURD calls this unit read function. It gets this. It sends this RPC to whichever server implements the file. And this here is our server-side implementation of the routine. So this, although it has TrieVFS in the name, that's just a prefix generated by MIG. So TrieVFS doesn't actually do anything with it. We have to implement it. And these arguments right here, they correspond exactly to the arguments of the RPC. Let's look at the RPC again, which would be here, IO read. So IO object of type IoT, that's our prot ID. RPT here, the reply port, those two are the reply port. Out data, this is data and data count arguments. And then we get offset and amount. Here they are. So again, this is just our server-side implementation of the routine. So let's do something fun. We have to return an error code, and if it's successful, we're gonna return 0. So let's if CRED is null, which can happen, yeah, in case you basically call the wrong RPC on something that doesn't support it, but something that's still implemented inside of a server. The request gets sent to us, but the lookup routine returns null. In that case, it's typical to return e open sub. So let's do that. Not sub. I never remember whether or not this should be 1p or 2 of them. So let's just try to build and see if it does. Okay. And then let's just assert that amount they want to read is more or equal to, and that cannot be error. Assert backtrace. That's what I want. Since there are no error to print, we just want to add the backtrace. Backtrace. That there is enough space in the reply message for 2 characters. There should be. Let's say set data this to y and data once first to backslash n and set data count to 2. Does this make sense? So I'm returning an array of characters, which is what I've read. And I'm saying that I've read exactly 2 of them, and these are y and backslash n, which is new line. Oh, and by the way, if you're not familiar, what we're actually implementing here is a clone of the Unix yes utility. So yes, it prints an infinite stream of y's. Right? You can type it into less or head or something. And what it's useful for is, for instance, if you have a command like update, right, and you want to answer yes to any prompt, it is this yes pipes to update. You don't actually do that though, because these days all these utilities have like -y flag to automatically answer any prompt yes. But apparently this was usable in original Unix. And what we're doing here is we're doing a device. It's gonna appear like dev yes, and you should be able to like get it to get the same effect, or you should be able to like head it, or you could take like apt update and use it. It's std. So instead of a separate command line program that you would pipe into another program, we're just gonna do a device. And the reason why I do this, talking about that, is that I have, in fact, a whole project dedicated to just that already written. So I'm just replicating that, where I have the same dev-yes device implemented for basically macOS, the HURD, Linux, and anything. And you can take any of this and build them. Each one is written in the recommended style of that kernel. So this is Linux style with tabs and whatever coding style. And for instance, Serenity is C++. And even the commit messages are in the style customer in the Serenity OS community. Yeah. And what we're doing now is a simplified version of that, of the implementation that I have in the repo, because that one tries very strict with like page sizes and copying many characters once. We're not going to do that because we're not after performance. We just want to get something that works. Okay, so back to this.
Just quick question. Yeah. Out of curiosity, this assert backtrace, this is just for your program not to crash, but in a actual implementation, you would have a kind of state machine. If you, yeah, it's probably useless because the buffer is always going to be large enough. But yeah.
Yes, the data count should actually always be large enough for at least 2, since MIG pretty much guarantees that. But again, in a production program, I wouldn't do that.
Yeah. Okay.
But the amount here, that's actually controlled by the user, and the user is absolutely free to set like send 0 or 1, and we should not do this at all, because this basically asking for trouble. Whenever the user wants to read a single byte, our program would crash right here. So this is just for a proof of concept, and we're gonna make this more robust in a second.
Yeah. Okay.
I just want to try this out and see if we can read some bytes from it. But yeah, do you guys understand this part? Anyone? What's unclear about this? We just setting the first character to y and the second to \n, and we're saying that there are 2 of them. And you know how on yeah, let's take what was I doing? This is on Linux, right? We can add trace here to see which syscalls it makes. And what it did, this is on Linux for now, right? What it did is it read from its SDN all of these. In fact, it read like 8 kilobytes of ends. And then it wrote the first 10 lines to its output. And on the HURD, we can do a similar thing with RPC trace. So let's we can do the very same thing with non-correlative in the HURD, and it's the same non-correlatives, not any different. And we can use RPC trace instead of S trace to trace remote prefix code. So we're gonna see quite a bunch of them, but the core here is the same. It did the IO read, ignores the request part. That's basically a bug in RPC trace. It did the IO read, got all of these, and then it did a bunch of IO writes to output it to its standard output to my terminal here. These Linux syscalls here that you get from strace, this correspond to these HURD RPCs that's traced with RPC trace on the HURD. Does it make sense so far?
Yes, it does.
Yes. So that's, well, I don't think we're going to know. It's not complicated. I'm not sure if you're going to do that. Maybe we should. But yeah, basically you have to track the offset somewhere. And yeah, just use that offset. This is just a super simple example for now, which doesn't track any state. We just wanna get our yes output. Okay, so let's build it. Let's copy it over, and let's use set trans to replace the translator. And let's see head temp the yes, and we get a bunch of y's, which is good. And then it crashes. And it crashes on trying to seek. But before that, we did really get a bunch of y's. Can you see that? How cool is that? Let's start the translator again and strace, or rather RPC trace our head. And again, see, this is a device. This is not a. Oops. This is not a like a program that you pipe. This is a device that you read. So with RPC trace, we can see that it opened the file, it read it, it said it wanted to read up to 8K, and this is -1 and 8K here. These are the values for offset and amount. But instead, we only returned 2 characters. And 0 here is the error code, which we returned here, meaning that there was no error. And then it wrote those 10 Ys, and then it tried to seek our device, which is changing the read and offset. And we haven't implemented that, and the default in TrueFS does nothing useful and started panicked. So I guess let's implement seeking. Or at least
probably if we
make it a crash.
This as a pipe or something similar, the tool wouldn't have tried to seek, right?
I don't actually want to implement seeking. I want to say that we don't support it. So let's do return ES pipe, which is the error code for trying to seek on a pipe. So now if we build it and copy it over and replace the translator and complete it like this, we should be able to do this and get a bunch of Ys and no complaints. How cool is that? And we shouldn't be able to write anything to it because we told TrueFS to only allow to open this file node for reading. And indeed, we get this. Actually, this is funny. This says read only file system rather than say permission denied, something like that, access denied. Specifically because TrueFS returns that error code because, I mean, not sure if it makes sense since it's a single node, but it is kind of a read-only file system. It's not a single node. But yeah, you can get Ys. So the second thing I wanted to do is an improvement. The original Unix yes program, it lets you, in fact, specify an argument of what to say instead of why. For instance, if you say yes HURD and get ahead of that, you can get a bunch of HURD messages, right? So let's add that functionality to our little program here. Let's track right here. Say const char yes string. And let's oops, what happened? And args char star argv. Let's parse our arguments. So if normally you'd use argp here, which is the GNU recommended option parsing framework for C, and this is what all of the Third's own servers use. But in order to not overcomplicate things, because I can never remember how to use it, I always have to look examples up. Let's just do the normal thing, which is if there is a single argument.
But
yes,
beware
going to be
your second parameter has the wrong name on the main function.
Indeed, thank you. This means somebody is looking at this. Thank you. And if it's still we do something else, we'd say yes string is argv1, right? And otherwise we'd complain. Usage run us with an optional store. Set. All right, does it make sense so far? So then when we try to read it, let's see. It shouldn't really even be size t. It should be like message type number t, like read size, let's call it. And it should be a minimum of 3. Okay, so let's do this. Read size is data count. If read size is more than strlen of yes string, what I call it? Yes string. Yeah, in this case, I'm gonna do this. Normally, you wouldn't want to compute strlen twice, but whatever. This is a simple example. And then, if it's still larger than what they asked us to read, let's use that. And this is again not completely correct, since we shouldn't be capping it at data size. If there is not enough space in the provided data array, we should reallocate it. We can always make our own data array, fill it with our data, and then Nick will do the right thing with it.
So if we wanted to implement this the complete way, then we would need to have some memory of the actual file that has been opened. So I guess that in the CRED structure, there is some structure that you can use and reuse from one code to the other.
So there is a hook thing in here. Let's look at it. Whenever you make the per open, you get to set your own pointer in it, which is called just hook. And this is whatever you want.
Yes. Okay.
You
Makes sense.
Store things in it, and then you can get. I don't think this is the same thing. This is probably another hook, but this is pointless. Like all the prod IDs should behave identically except for credentials. So you're not really supposed to store anything in a prod ID. You are supposed to store things in the per open. We should, in fact, look at that example of mine. The real implementation of JVF, not this simplified one, that does use the hook and support seeking and whatever. Let's look at it in a moment. Now I just want to do the simple thing where I support more than just Y. Let's copy onto data from our yes string the amount that we want to read. And we have to tell the user that we read this much and return success. Rebuild, not this, copy it over to the machine, reset the translator, still works normally. Now let's reset the translator again, but this time, actually, see, if I call it like that, it says must be started as a translator, but if I say this, it should say usage, provide me with help how to use it. And this is the reason that we don't like hard require you to start as a translator. You can do useful things with it without starting as a translator. Namely, you can view its help and version, and you can do this like third CFS version and say something about version or like help. Right. So this is a useful things that the binary itself does, even when it's not being started as a translator. So that's how you normally write your main. You parse your arguments, possibly output help, and then you would check with your translator and error out everything else. Okay, so what I wanted to do here is tell the existing translator to go away and set a new one. But instead of yes, I'd add an argument right here on the translator command line. And let's try to read the node now. and says HURD a couple of times. And this is actually quite, didn't stop. It doesn't have any new lines because we haven't added any. So what we really should do is we should insert like a new line after the argument, because that's what the existing Unix thing does. So let's have some logic here for that. Yeah. Let's see, len is len of argv1. Yes, string is malloc of len plus 1 plus 2. Okay, and copy yes string argv1 len plus 1. Just len is fine. Yes string len is /n, and yes string len plus 1 is a null terminator. I guess you can use in some nicer way, like starcat or something, but this will do. No, it won't. What now? Let's redeclare yes string as non-constant because we're allocating it now. Yeah, so this works now. Okay, I hope that was interesting. Now let's actually browse my full actual implementation over on GitHub, which has quite a bit more functionality, including keeping track of the reason offset, which is what we wanted. I wrote it 4 short years ago in Nano. Yes, it supports reading and writing, both of them. So this little program, it's used much like ES1. It used the command line argument to specify the string to duplicate, right? And this full implementation that I have, it instead lets you write to the device. So you'd open it, write a string into it, and then read it back. Only you probably can't read it because it's too small, so let me enlarge it. This is better. It should be like this. Yeah. So this, yes, including the offset, is what I track for basically every per open. And then there's a thing called open hook, which you can set in here. So basically you set TFS open hook to a function pointer. Yeah, like this. Oh, it's different. This is per open create hook. Okay, yeah, there are more hooks where you can basically hook into various things that TFS does. In this case, it creates a new per open. So basically somebody is opening the file node and you get to store info about it, whatever. And I was just allocating this structure that I track and setting this as the hook pointer on the per open. And then you get the close hook where you'd free a structure and set the hook if you want. And then start, I say that I am a character device of size 0. Go away, again, it's just exit. Readable is where you should say how much data can be read without blocking, which is really arbitrary in this case because any amount of data can be read, but I set 2 page sizes since it's a good size for reading. And reading implementation is somewhat complex, but again, see it's through the prot ID, it gets to the per open and uses the hook pointer to get to my structure that I store. And then I have this thing called exploding, which is instead of like this simple implementation that we had here, it copies like a single copy of the data to the user, which is fine for the purpose of the demo. But my goal with this was to be, in fact, faster in outputting data than GNU's Yes program in all the ports. So in all of the ports of their Yes, not just the HURD, I wanted to do better on the raw performance than GNU Yes. And this is, of course, completely, utterly pointless. Nobody is really using the Yes program since the Y flag exists, right? Much less is anybody measuring the speed, like how many gigabytes of Y it can output per second. But you can do this. You can measure it like this, right? And I don't have EV. I don't. Okay, whatever. You can measure the speed. And I wanted to do better than GNU Yes. And GNU Yes uses the streak of explosion, and so did I. So I create a new basically mapping of like 2 pages, not here, in the explode function. Here, yeah. I create a new mapping of size like 2, and I copy the target string multiple times over it. And then I can return that to the user much more quickly. And indeed, I track the reading offset so that I actually support 6. You can, well, either you can read like 1 byte when the Yes string is multi-byte, and it will do the right thing, or you can stick to anywhere. And it will also do the right thing.
This is a bit similar to the unroll loops, a technique.
To what?
The unroll loops.
Unroll loops. Yeah, I guess it is. Well, I didn't come up with it on my own at all. I just basically, I guess there is this Stack Overflow answer about GNU Yes performance. GNU Yes performance Stack Overflow. I guess it's Unix, our Unix Reddit post. But yeah, like they're discussing how many gigabytes of Yes you can output, and I wanted to, I wanted to do better than GNU Yes, since I got the advantage that I'm not a program that has to like send its output through pipe. So in this setup, what you have is Yes is a program. It sends its output to a pipe. Basically, this is a copy, and then PV in this case, of whoever's on the reading end, reads it from the pipe, and this is another copy. And then you get, well, in this case, 10 gigabytes per second. But in my case, I'm a device. I should be able to do this with a single copy. So potentially, I could get you a lot more Ys in a second. And indeed, originally, both my HURD version and my Linux version have been like 1.5, I think, times faster than the GNU Yes with pipes, but I'm not sure. But then it doesn't reproduce the day. For some reason, my Linux version is not that fast anymore on modern Linux kernels. Actually, let's, just for fun, this is not related to the HURD. Let's see if I can still get it working on Linux. So this is the Linux version, and I actually have it built, I think, but let's rebuild it for my kernel that I'm running here. It should be called yes.ko. Yeah, and I should be able to sudo insmod it like this. And it was there since it's not signed, so yeah, I'm not going to be able to test right now. I have a robot or whatever. But yeah, on Linux, it shows up as a device like dev yes, and you can actually read from it. And if you wanted to get the same here on the HURD, you'd create the dev yes node. Well, basically do this, except you wouldn't make it an access translator. And you would create the actual dev yes, no, what things. Yeah, what is this? And get permission denied since I'm not root. Let's change that. Yes, so now we should have actual dev yes that works as you'd expect. Cool. So now let's get back to AR64 and glibc patch that. And then maybe if we can get the AR64 system working, we could test our yes translator on that. Okay, so this was glibc. So the one thing that we have to do manually is fix up the libc sol file. So libc sol gets installed as lib/libc so. It's not actually a shared library. It's a linker script that tells you to use the shared library. But also the static bits, the linker. Okay, this didn't get overwritten. This is extremely unexpected. Should have gotten overwritten. And the reason that it hasn't is because it must have created user. And that, of course, means that previously I have not. What is this? Yeah, that's not supposed to happen. Let's do this another time, I guess. Yes, I want to drop it. Yes. Okay. Exit build. CD build. Configure. The prefix is going to be nothing like this. Run a build. Okay, we have some more time. Let's write a translator that does either cypher on top of another node. Shall we? Anyone wants to see that? So the idea here would be that we have an existing file somewhere on our file system, which might be, well, which is definitely provided by some other translator, but it might be something boring like XFS, or it might be something more exciting like HTTPFS. And we wanna make a translator that lets you basically read and write that file, but it wraps every operation into Caesar's cipher, so it shifts bytes. So you could use this to encrypt and decrypt, or the other way around. So while this is building, let's make another directory. Caesar FS. Am I spelling that right? Caesar. No, doesn't look like I am. CAESAR. CAESAR, like this? Yeah, Caesar FS. And let's copy over our make file because it was yes, file to Caesar FS. Okay, it's now called C. Okay, that's the most complicated part about this. It's typing all the letters right. Caesar.
So, quick question. When we get credential information, that would, in theory, make it possible for a translator to answer a different content depending on the UID, for instance, right?
Yes, you could do that. I don't know a good use case for that. But you could do like a magic file that reads differently, yeah, depending on who's asking. But again, this is likely to take programs by surprise because most programs are not written for the HURD. They just assume that files are like normal regular files. But yeah, you could do that.
Yeah. I think it makes a very big difference with the notion of VFS that we find anywhere else, where there is only one root, and you can ch root some programs so that see a file system that is different, but in fact the tree is the same. It's just that the root has been hooked somewhere else. So with the HURD and the fact that the translators really generate the structure, so yeah, we are not bound to this one and only one tree model.
Yes, in theory you can have multiple, and this is kind of how subHURDs work. When you start a subHURD, it starts a new root file system for itself. So in a way, that's just a different subtree, plus its own process server and whatever. As far as file systems go, this is just a second tree file systems. You can, in fact, do root on HURD as well. And unlike Linux or traditional Unix, where this, well, let's try it home. And this would say operation not permitted, since this is a privileged operation on Unix, and for a good reason. Is it still, yeah, it is still building. The reason being that you could trick set user ID programs into basically reading the wrong configs or something. If you are allowed to root as a non-privileged user. Like you root and then you'd run sudo inside the root, but then you'd control basically sudo's config inside root, and it would believe that you can get root, and then you would be able to escape from there. But this is not an issue on the HURD. You can totally root. Well, in this case, there's no bin shell inside my home, so it won't be bash such a command prompt. That's stupid. I believe it's in sbin, and that's you can skip it since you don't have to be privileged on the HURD to do it. Yes, so there is no bin bash inside my home.
Yeah, this is not a viable route.
Yeah, I don't have a chroot prepared, but chroot itself is not a privileged operation on HURD. If well, I wasn't there, so we, as the HURD developers, have solved this in a different way. Basically, whenever, even if you're inside chroot, whenever you start a set user ID executable, it gets started in a fresh environment, one that you cannot directly influence, including its root. And yeah, I don't think the working directory is fresh. It is inherited, although it is authenticated. But the root directory, it gets a fresh one from its exact server. So basically, even if you're running inside the root, if you run sudo, it gets started outside of your root, which makes it safe for users to run root. And this wouldn't, like, it wouldn't even make sense to not let users run root, because on the HURD, every process itself determines what its root is, right? It's just whatever you store as your root port. Well, this is done inside libc, but there is no way to like prohibit a process from using a different port as its root directory. You can do that. In a way, that's similar to fake root. I think that's what it's called on Linux, which is it's a library that you can LT preload in your process, which will like intercept all system calls that you make and append this root path to them, making it seem to you like you wrote it, even though you actually aren't. And in that case, too, if you like execute sudo or something, it won't pick up the same LD preload, because Sergey executables are careful not to pick up LD preloads and other sensitive environment variables. And again, it would appear to run outside of the root, even though technically we were never in it. So in a way, that's similar to that, except that on HURD it is like a natural native thing. And again, I hope all of this, or at least some of this, makes some sense. Okay, so this build is still running, and we should, let's maybe close a example. Let's open the new one that we have. next to it. It should be Caesar, but I'm not seeing it because it should be this. This, okay, let me complain for a second here. This is a stupid hardware bug. This device that you're seeing, this is Microsoft Surface. I could pull up my settings here. The Microsoft Surface. It's a like 2-in-1. It's a laptop. It's also a tablet at the same time. It has a detachable keyboard. I can use it as a tablet. I can use it as a laptop. It's awesome. Yeah, it's made by Microsoft, our arch nemesis. But it has this hardware issue, which is if you use a third-party charger, which I have to, since my original one broke down last year. Apparently, it causes some sort of electrical, how if I know, interference with the keyboard, which contains the touchpad. It starts to glitch. So basically, I can't have it plugged into the charger and use it at the same time. I can, but it's likely to glitch. So I typically leave it to charge and then unplug it when I come to work, and then plug it back again when I go like to eat something or whatever. So yeah, it's still 68%. Should be enough for us to use a feeder of make file, and let's make the main file next to it. This should be Caesar. Okay. C FARFS.c. Let's copy some things over. This just is not gonna have. Let's increase the font size. It's first type. Still gonna be missed. Capacity is still gonna be a PID. Allow open. We're gonna say or read or write, both of them, and this is gonna be both of them. This we're gonna do something about. Let's think about it later. Exit 0 is still fine. Let's copy over a main for now. Except that we're not gonna use a yes string. We're gonna require the user to specify a file name of our underlying file. We're gonna have like file name, I guess. Let's, yeah, what I should really do is store it as a file T rather than IOT, underlying file. So IOT, much like many other things, is basically just a MAC port. So this is going to be a port to some other file that we're going to translate using Caesar's cipher. We require there to be a single argument, and we're going to open it by doing file name lookup. And file name lookup is, let's grab it, function that libc provides. Include, yeah, here it is. Actually, even in just HURD, we should include HURD. And it's built. We should do just dir. Oh yeah, exactly. So file name lookup, where is it? Right here. Is a function whose signature looks a lot like Unix's open, but instead of a like file star, or I guess Unix's open returns a file descriptor, and this thing returns a file T, which is yet another type def for MAC port. So this is HER specific, provided by libc. which you can use to get like MAC ports to a file. The path is going to be argv1. Flags are going to be all reads or write. Can go ORD this. We're going to do update. We don't want to create it if it's not there. The mode is going to be 0, so we're not going to be creating it. And if it's now, we're going to report an error. I'm going to use error no as error code and say failed to open this file. And the file is argv1. And to use error no, we might have to include error no h. Okay. Let's see if this builds. Yeah, this file should be named Caesar rather than Caesar fs. Now it does. And it's this thing, so let's oops, I catched. Happens. So this here is going to require us to file. Okay. Yes, we copy our Caesar. And here we should be set trans in temp. They call it temp C using temp Caesar. And this won't work since it's supposed to say, okay, this is installed. It's supposed to say this, but it didn't. We should be doing this thing. Yeah, exactly. And let's use SPACD, I guess, or S place as a file. And we cannot open it for writing. That makes sense. Let's make a temp test file. Right. So now we should have the temp Caesar node. It doesn't yet. We cannot yet read or write it, but it should be a node with a size. It should present itself as a writable file, which it doesn't. And this is weird because it's called temp C and not temp Caesar. Yeah. Okay, so it should now look as a writable file like this. Right. And the size of it. Okay, actually, you know what we're gonna do? Whenever we get a start request, we're gonna get our underlying file, and we're gonna start that. IO start, is that it? Yeah, so the routine is IO stat. It just takes an IoT and outputs the start buff. So let's call IO stat on our underlying file and tell it to write to the same start buff that we're supposed to fill. Let's just check it doesn't result in an error. Technically, we should do something to handle the error here, since this is a different file. Who knows which sort of an error could return. and this cannot propagate it. It turns void. We might fall back to some default stuff. But we won't do that. Let's just assume for now that the file can be started, the underlying file. And let's reset it and start it. Compare that to our test file. They should look identical. They should have the same modification date, in the same size, and the same mode. And in fact, if we chmod, say, drop the right permission from the group on test file, it should automatically drop from our file here. So cool is that. Do you guys see the change? Anyone? Not quite hearing you. Okay, let's implement trading, I guess. Intercept the scale, of course it did. So again, this here is the signature. And once again, we're not going to do any asynchrony, so this we can ignore. Let's, I guess, call IO read on the underlying files. That makes most sense, right? And it takes
these IO functions. They are the functions that are under the glibc and that are used to implement the normal read and write.
So again, these are the MIG routines. Basically, okay, let me talk a bunch about MIG again. And while I do it, let me plug in the charger here, the chargers I'm taking. In a way, the HURD, well, the HURD is many things. The HURD is, GNU kernel project. The HURD is the replacement for Linux in Debian. The HURD is the only successful microkernel project, right? That can host the whole Unix on top of it. The HURD is, well, many things. But one other thing the HURD is, it's basically Unix layered on top of MIG. That's it. That's why it was so easy for me to get into HURD hacking, because I was already familiar with Unix, I was already familiar with Mac and MIG, and I just, opened up the routine definitions, and I saw that it's basically Unix expressed in terms of MIG. What could be more natural and make more sense, right? So basically, every Unix operation, there is a corresponding MIG routine. Whenever you want to do some Unix thingies, such as open a file, or read from a file, or send some data to a socket, or exec, and then Unix exec replaces the process. That's just a MIG routine call. So the IO read is one of the MIG routines in the IO subsystem, which is a subsystem implemented by various things that want to be, behave like IO streams, like files that can be read and written, and then there are a million other things other than just reading and writing, such as tab to 15. Let me pull up the files so you can see what else is there. like writing, reading, speaking, open mode bits, like whether or not open for reading or writing or async, whatever. Async IO, which is broken. Owner is for like terminals. You have like the owner process, which is, yeah, actually a little as an aside. This IPC, this RPC here is really broken. It shouldn't have been done like this. It's probably too late to change it. It's broken because it expresses the owner, which is a process, in terms of its speed, which would be logical in Unix, but it doesn't make much sense in HURD. It should have passed something like a process port here, because speeds can change. Process ports can. This is a lot more capability like. But yeah, that was an aside. And then there are a bunch of things for various asynchronous things, mainly IO select, which is what underlies select system call and poll. And in my implementation, also epoll, and then stats that we've seen, and then authentication, which is what's used to create new of those prot IDs. Basically, whenever you want to change your user ID, you'd take one IoT and you'd call this, and there's this handshake procedure involving the host server. And you'd create a new host object. Well, also this is wrong. This should not say host object. This should say IO object. Somebody could submit a patch, change this line to say IO object. But yeah, whenever you want to change your user ID, or group ID, or whatever, you call this IO authenticate, passing an existing IO object, and it create a new one. And IO object, what the user calls it, the server calls it prot ID. Restrict auth is basically the same, except that you don't actually authenticate, you just restrict the user IDs that you already have. So you don't have to talk to the auth server to confirm that you have the ID you already have them, you just run a subset of them. Duplicate is useless. I don't know what uses it. Let's actually get libc. Maybe there are some uses. Nope, doesn't look like that. So yeah, why would it do that? I have no idea. Server version, let's declare the version basically, which must return this info probably. Oh, by the way, I didn't do that. Let's do that. You can unplug the charger. You can set more info, which is like retrieve fast server name this, right? You can actually set this. Let's call it Caesar. And I can now spell this right. Caesar. And you can even set a version for yourself. And again, as you can see, you do this by just declaring globals. Let's call this 0.0.1. And TLFS will presumably export these variables that you set from this routine. I don't know how to actually use this routine now. Does it use it for the source tree? No, doesn't look like any stuff. But yeah, somebody could call this and get info about what else it implements this file. Then a fun one, IO map, which is implemented by file that can be memory mapped. If your file can be memory mapped, you're free to return either to nulls, I guess, or something like supported. Then these two, and there are more actually on release conch, whatever conch stuff. These are defunct. It looked like they were supposed to be used for some more mapping stuff. I don't think this ever happened. This just kind of exists and nothing uses them. Yeah, all of this. I'm not real. This is for getting pass information. This is for, yes, identity port. That's a rather obscure thing, but yeah, let's not get into that. Revoke is for the Unix revoke call, which is basically, you have a device. It's not implemented by Linux, I think, but some BSDs have it. Basically, you have a device and you want to revoke access to it, even though it's already open. So you call revoke, and other file descriptors that refer to it start getting errors when they try to access it. And then the new one, which is the same as IOSelect, but it has timeout expressed as an explicit argument here. I think the original either didn't have it at all, or, yeah, it has it as a wait time. And wait time is not an actual argument that's transferred over the, like, over IPC. Wait time is a MIG directive that tells the generated routine to wait this long for a reply from a server. Whereas in the new one, in IOSelect timeout, timeout is just an argument that gets sent to the server. Question, I'm not working on TrueFast. What do you mean? I'm not working on TrueFast at the moment. I'm explaining how to use TrueFast. Yes, what I was saying is that all of these are routines defined in the, in this case, io.devs in HURD source tree. And then MIG, the tool, it generates, based on this definition, it generates basically a client-side implementation and a server-side, not implementation, but a bunch of server-side plumbing. And then on the client side, you can just call it much like a regular function, because at the end of the day, it is one. And what it does is it basically stores the argument that you pass to it into a MAC message, and then sends the message to the server, waits for a reply, and then reads the out argument from the reply message, and then passes it back to you into your C code. And on the server side, you implement, or if it wasn't for this prefix, it would too look like just like the C function. And then, yeah, the plumbing that MIG generates, it would call your function whenever a matching message is received. So the IO read function itself is generated by MIG, but it is located inside glibc. Specifically, it's libhurduser.so, which is just a bunch of MIG generated client-side routines for the HURD definition, including the io.devs that we're working with now. Does it answer the question?
Yes, thanks. It's pretty clear now.
Okay, so IO read. Yeah, let's pull this up again. So we pass the object, we don't pass the port, we get the data, which let's just pass whichever data the client has passed, which is a neat trick. Okay, so data and data count, exactly the same data buffer, will pass to the file. So basically what we're doing here is we're asking the underlying file to read itself into the same buffer that we've been asked to read us into. And then we have to pass offset and amount. And we're going to do the same thing. Like we're just going to pass everything through. And if that returns an error, guess what we're going to do? We're going to propagate the same error to our client. Cool. If it doesn't, though, we need to apply the scissors. Let's implement it. Static void either. Child data. Safety side. And we should have, let's just use 13 and not 3 as in the original scissors cipher, because 13 is reversible, right? You can do it twice and get back to the original text. Okay, let's remember some very basic C code. And I for I is 0, I less than size. Plus. So we're looking at data ice. If is either less than A or more than Z, we do nothing. So we pass through various row bytes. Otherwise, let's take data I, subtract A at 13, Z modulo 26, and add A back. And that is our encoded character, which we write back to the array. Right? Does that make sense? Hopefully. We should also do the same thing for capitals. We could, in fact, just do a second iteration of the loop for capitals, which is, of course, not the correct solution, but who cares? Yes, here we apply that data and data count, data difference like that, and it should turn 0 as well. Actually, no. Since, well, yeah, maybe I do. Let's think of it. If multiple, yeah, I think you're right. So if multiple clients connect to me and they ask, yes, they each should have their own position. Yeah, I should need to seek indeed. Let's remember that for later. For now, let's assume that there's just a single client and they read in our file, and like we read in the underlying file, it's all at the same position. But you're right, we should seek for the more general case. And somehow this compiles in the first try, which is something that should never happen. It always makes me nervous. I might have, yes, this still works. And then let's, the original file just had hi in it and a new line. It should not get translated. And temp C, it has something which must be our translated message. Let's get some lorem ipsum. Yeah, looks like it does something. Cool.
It is pretty cool.
Yeah, so now there are two things that I'd like to add to this tiny little program. First of all, we should support writing things back, not just reading. We should be able to write, and writing should apply scissors first and then write the either N or D crypted, whichever it is. And the second thing is what I believe was Almu who said that we should seek writing or reading, since there could be multiple clients and we don't know where we are in the underlying file. So let's track each client's offset. And we're going to use the hook for that, the one that we talked about earlier. This one. Technically, it's a pointer to whatever we want to use, but we're just going to store like an integer in there instead of a pointer, because I don't want it to like allocate memory, whatever. So we have the open create hook. This thing. Let's copy the signature. It's going to be our open create hook, which I should define. which would be RT peropen create hook gets the new peropen that has been just created. And if it has been just created, its offset should be 0. So it says the hook will be that the hook is 0 and returns success 2. If we allocated anything here, we'd have to also have a close hook with freed. So then here, let's pick an offset. If either the user can pass in their own offset, in which case we should ignore this one, this torrent, and just read that offset. And this corresponds to Unix's read P, I think it's called. No? We read period, of course, period, which is variant of the read call with an explicit offset that doesn't move your like tracked offset, instead uses an explicit one. File offset is not changed, says the one page. Or this can be -1, in which case this uses the file's own internal tracked offset, which should get increased by however much we read. If it was -1, let's set it to PO hook, right? And cast it this to OP. And then the underlying file, we ask it to read and that at that specific offset and never at -1. And then we should update this. So let's in fact do this. LFT effective offset, and we'd set this. Else, we're going to set it to the offset that the user has passed in, and pass effective offset here. And then in here, if it was -1, then we're supposed to move forward whatever we stored. So hook is, yeah, this is going to be weird. So we have to cast it to chart star like that, and then add the amount of data read like this. Let's see if this builds. No, so we don't have PO. Don't indeed. So PO is struct pass rods rather per open PO, and that's just create PO, except if I write it like that, that would be a potential error. And yeah, in fact, we should check for that. I forgot to check for that. So first thing we do in practically any function, practically in any mixed server-side routine implementation, is we should check for this, whether or not this is null. And if it is, return an error. Because, as I said, this happens if you send an RPC to a different port that's also hosted in the same server and doesn't support reading at all. Like not a file port, some other thing like file system control port. So if correct is null, it should return PO not stop. And after that, we can dereference it. Set PO to create PO. Get a bunch of warnings, custom integer of a different size. Indeed. So let's start by casting it to uint pointer t. The safe size. The other one is that we discard const, which is fine. Let's drop const here. Yeah. Replace the translator. It still works, except we get a bunch of new lines. Okay, so one thing we can do, which is fun, is we can insert RPC trace in here. This is like a little secret. I don't think many people realize this. But the bootstrap port actually gets inherited over fork or exec or other things. A program that's not a translator typically doesn't do anything with it at all. So you can do things like, instead of a translator, insert RPC trace here, and it will spawn the translator as its child, and it will pass over the bootstrap port that it got from its parent to the child. So you basically see RPC trace with C any calls that the translator makes on this here on the terminal. And these were just the ones that made to start up. Now let's cut the file. So we're seeing both the calls that are made to it and the calls that it makes itself. Cut. So if get root is not actually a call that cat makes, it's a call that, in this case, x2fs makes on it to get its root node. And this notation in RPC trace output indicates that the call hasn't finished. Instead, something else happened. And it got finished right here. Basically, this means that the translator requested IDs on an house handle for some reason. And then, yes, it actually calls duplicate. And then it allocated a new port with a protected payload set on it and moved it into the port set and returned, requested the notification on it, or rather no senders notification on it to know when there are no senders to this port and can be allocated. And it returns that port from the get root RPC. And then cat, no, that was somebody else. I bet that was cat testing indeed that this was not a terminal. But I think this not because cat made it, but because it got sent to our server. And then it started and started. But actually, yeah, they tried to start our port, our file. And we started the underlying file. For some reason, looks like we did it twice. And then we replied to our start request with all the same data. And then they tried to read our file, -1 being the position, meaning the current file position. This is the amount we passed here. And again, this means that it hasn't completed. Then we tried to read the underlying file at the position 0. So we have specified an exact position via this block code here with the same size. And we got, for some reason, 2 /n's and then all this text. And we must have replied to that somewhere, which I'm not seeing. We must have. And then again, I just tried to read more, again using the current position, its current position. And since tracking that, we sent the effective position, effective offset to the underlying file. And since that was the end of the file, it returned that it had no more data. And so did we. And so cat terminated. And then we got our no senders notification. We checked whether or not it indeed didn't have any more senders left. And this line here, this is actually my fault. One of the things that I did in 2021, I believe, was discover a bunch of vulnerabilities, including one where it would believe various things you would send to its port as if from Mac, including a sender's notification, without actually verifying they came from Mac and that they are legit. And it would do things to ports automatically based on these notifications. And you could use this to get it to like basically free a port that has been that was still in use. And that of course is bad. You can then exploit this to get root access or whatever. So now it checks So this line is in RPC trace output is actually my fault. Yeah. Let's reset the translator again to get rid of RPC trace. We don't want it anymore. And we should, in fact, see the old translator being asked to go away with that fc go away call. We should call our JFS go away implementation here, which is just exit 0. Yeah, see, it says fc go away. It didn't complete. Instead, it's exited. Unix exit translates to proc mark exit with our exit code, which is 0, and task terminate, where it just terminates self-mark task. So temp test file, it really starts with two blank lines. Right? And if it didn't, again, they report the same size, which is good. That's what we want. And output of cut doesn't either. Cool. All right. So technically, we should be able. Let's try that. What I want to try is let's open a second extension here, and let's open Python in both of them. And let's in both of them open the file temp.c and it crashed. Okay, what happened? We didn't implement stick. Let's do that. Let's implement stick. And let's again steal some code from here. We won't return an error though. We do the actual implementation since we track the offset. So the way stick works, this is just a general Unix thing rather than a HURD thing. There are three options which you pass via the once argument. And again, I don't know why stick would need any asynchrony. Why do they pass reply ports here? Whatever, we'll just ignore it. You can either stick to the start or relative to the start, which is basically setting the exact position you want to read at. You can stick relative to your current position, like 2 spindles backwards or 10 bytes forward. Or you can stick relative to the end, like 10 bytes before the end. And the later is most useful if you have like a huge JSON file, which is an array, and you want to append an empty to it without like reading in and then writing back all of the huge JSON. So you just seek one before the end, which should be the closing brace, and you'd append your last entry and the new brace. So it can be done really fast without even reading the whole file. So you specify one of the three options, the offset relative to that, and it returns the new offset. And in fact, one of the common uses of seeking is just to get your current offset. You say seek relative to current position, change nothing, but you always get the new offset back, so you learn a new offset. And let's steal some logic from my yes implementation here, because I already wrote there. Seek. Yeah. So again, first thing you do is if you don't have the credential here, that means it wasn't really a file that they tried to seek on. So you must return eopnot sub. It's not that you must, you could do something else. And the process server, in fact, does that in some cases, and I believe that to be wrong. You shouldn't do that. But it's fine, it won't cause any real trouble. But you cannot, obviously, you cannot reference it if it could be null before you check it. So after that, we can switch like that. Yeah, all of this code. The length should be one of the three values. Seek set means just use the offset as is. In other way, this is seeking relative to the start. Seek end means seek relative to the end. And that's a fun one because we don't know where the end is. And to do that, we should ask the underlying file. So let's do that. Something seek on the underlying file. So the underlying file, we always reading it at a specific offset, never at -1. So it doesn't really matter where in that file we stand. So it's fine to seek it just to get its basically what its size is this way. We could instead do stat to get size, but it seems more appropriate since we're going to speak. Offset is going to be 0 in our case. Length is going to be seek and new p. Let's pass the same one. So if an error happened, we can do nothing but propagate it. If an error didn't happen, new p now contains the offset relative to, well, new p now contains basically the underlying file size. So the offset they want to seek to is this plus new p. And if we want to seek relative to the current offset, then we should take, let's declare per open in a similar way here. So per open, if we check, I can dereference it. So let's take PO hook, cast it to whatever that was, uint pointer t, and it to offset. So offset should now contain the offset that they want to seek to relative to our file's start. When and that they pass any other values, then it's an immediate inval. So now if that offset turns out to be negative, that's an error as well, and we change nothing about real offset. If it's positive, we can assign it like that. Assign it to what we store, and importantly, assign it to new p. Let's do
maybe
this.
an alternate possibility would have been to set the hook to have a distinct IoT open for the underlying file for every client. Because then the offset would have been the offset of the underlying.
We could do that. In some ways, that might be better. I don't know. But indeed, in that case, we wouldn't have to care about offsets at all. We just pass everything from our client as I did before, and let the underlying file deal with multiple clients.
Yeah. Well, implementing it by hand is certainly more interesting for people watching. So
yeah. So this way we cast it to void stuff, right? Now let's cast it to uint pointer t to avoid the warning. Yeah, but most importantly, we must do this well, equally. Both are equally important. So we must update our own offset as we store it, and we must return it to the user. So that should hopefully work. Build it, copy it over, restart the translator, Python. Let's attempt to get some hits. Let's attempt to open the file. Yep, open it here. And let's read the line. Yep. So we read the line, and then let's attempt to read the line here. And it should read the same line, thus proving that the offsets are independent. Let's read, like, say, 10 characters in here, and then read 20 characters in here, and then 10 more in here, right? So they all match up. So we can have multiple clients reading the same file at different offsets independently, with offset being tracked per client. Cool. Then the only thing left to implement for this little demo is writing. So let's do that. write. Copy over the prototype. Seek read. Let's place it on the read. And again, prot_ADT iObject is rather this. And this is const char star single star. Align this for nice niches. Do this. Cool. We have to run the CSS conversion before we write it to the underlying file. And in this case, we don't have the direction. So the data is already in existing buffer. It's counted already in existing buffer. It's technically const. So let's const cast it away. It's not technically okay, but it's gonna work. Offset mapping. Let's do that. Yeah. Finally, let's write it. So instead of IO read, we're gonna do IO write, and that's basically the only thing that's gonna change. I don't think amount. Yeah, okay, amount is the same. So amount is how much we were able to write. So here, what happened? This is subtle. See, in read, amount is how much it wanted to read, and how much it actually read is returned in data count, because this is an out argument. This isn't like an out buffer. So there is this extra level of indirection here. So how much data it was able to read is returned by the size of this out buffer. And in write, it sends us a buffer. There is no indirection here, but amount is an out argument. So we'll tell it how much it was able to write if it didn't accept all of its data. But again, in this case, we're just gonna pass through all of this. Well, I mean the same amount variable. We're gonna pass it there, and it's gonna set it just like we want. But right here, we should use amount instead of data count, since that's how much it was able to write. So we should update its offset by that much. And we should return 0. Hopefully this is gonna build. Nope. Would it appearance amount dereference, of course. Let's reset the translator. Let's echo hello HURD temp C, and it crashed. What? Did not set supports right. We did set that. Maybe we should implement this. Maybe there's more to rating than just set size is what Unix calls truncate. Yes, let's implement that as well. Second case hooks. This is once again UFS prot_AD CRED. Useless reply ports, and a new size. Check this. Don't even need per open, I think. Let's just pass this through to the underlying file. File set size, underline file, new size, and we can just return it without directly to our file like that. Let's try this. Yeah, I know it's complicated. Temp file should have the encoded version of that, and temp C should have the decoded version. So basically now if you wanted to say me and Joshua wanted to like secretly chat, we could like set the translator, write a message to the translator file. The translator would convert it to I'll basically do the drop search transformation. I'd send him the translated file, and then he'd run the translator and read the decoded version.
This is
nicely done.
Thank you, Sergey.
Can't hear you.
I was saying that it was really cool walkthrough. Thank you.
Actually, let me, you know what, let me upload this somewhere so you guys can like look at it offline. And it doesn't open. Let's try the other browser. No, it doesn't. Okay, let's try something more stupid, like what was the Debian paste bin? Okay, I set language to C here. Expiration is never. Name is gonna be Caesar. Let's see, is it right? Wrap text, whatever. File send. Yeah. So let me try to send it to chat. Okay. Get it? Yeah, also let me send all the other links. So this is regrep, just if you wanted to see it. JVS is not interesting enough. Yeah, I mean, look at it. It's not even long. It's like 200 lines of code for what is a file system, basically. Now let's get back to AR64 build. So we have libc installed. Let's try the HURD proper. And also I'm gonna change to dark theme here. It looks like I have some changes. And this makes sense because I don't wanna use page size. Instead I use VM page size. So this is fine. So does this. Yeah, this all looks good. Let's make a temporary commit. We'll write a proper commit message later. Page size left. Let's rebase on top of origin master. Yeah, let's see and do it. And let's speed it up with J8. And we get an error. Right, we should have. Because this time, libc got installed into a proper location, and we should have to fix this manually, which is what I was trying to do before. Right. So for some reason, or for clear reasons, yeah, this ends up suitable for basically being used on the target system, but not as a cross, like as part of a cross toolchain. For it to be usable as a part of a cross toolchain, I have to insert prefixes here manually. And also I have to apply this, which is not related to prefixes. L Mac user, L HURD user. This patch is stolen from Debian. They apply this to their build of libc that they ship. Basically, if you look up user lib i368 GNU libc, so yeah, it's gonna have this line. Actually has input in it, which I never noticed. And I stole that from them. If you don't do this, basically this implicitly links in Mac user and HURD user libraries, which are part of libc, much like say libm or libdl or libptret. These are all part of libc the project, but you have to link them in explicitly if you want to use them. Instead, this changes it so that you don't have to link them in explicitly. The reason is that many programs basically forget to link them in, and also that you get them for free without any explicit linking them in if you build statically. So this does the same if you build dynamically. I don't quite buy it. I'd rather have every program that wants them specify them explicitly, but that's not how things are. So we have to enter this every time. Yeah, every time I rebuild and reinstall libc, I have to patch this file like this for cross compilation to work. And again, cross compilation, well, I mean, Git people should know that better than anyone. But yeah, cross compilation is HR. Cross compilation is always complicated. And I'm quite happy with the setup that I have here. Basically does everything that I want. I can build code for the HURD from my Linux box, which is much faster than any of the HURD boxes due to multi-threading, SMP, and whatever. Right, so it built. So you should have a bunch of stuff, including, for instance, X2FS static, which is a statically linked ARch64 executable for the HURD. We should have exec server, which is the second file that starts, which is dynamically linked, and we should have the dynamic linker installed already in the prefix. It's called LD AR64 so on. We should have, yeah, lots of things here. So let's now try to assemble a very basic root file system out of this to be able to start some things running on AR64. I have some previous stuff here. Let's move it away. Let's call this the past old, make a new one. Fact. I wonder if the old RTFS was owned by root and not me. No, it's all sorry. Okay, fine. All right, so we should have at least def, lib, libexec, and servers. Let's make those. Def, help, lib, libexec, servers. I'm not gonna install everything onto there for reasons. We need the image to be really small to fit under basically 200 megabytes, I believe. So we're only gonna take what we think is needed. Yeah, and on the servers, we must create these two nodes, exec and startup, because yeah, the exec server, it's not even the exec server, the root file system, which is gonna be X2FS, is gonna look for /servers/exec, and if it's not found, it's gonna die. And the startup server, I think it looks up that node itself. So these two nodes must be present, just empty files, but they must be there. And startup all servers, exec, startup. If not familiar with the HURD file system layout, let me show that quick. Wow. Core files, let's drop them. Yeah. So it's much like the regular Unix file system layout, except for these two new directories, HURD and servers. /HURD contains a bunch of binaries. It's much like bin, but it's not in your path. So you cannot accidentally run one of these. And these are all translators that you're supposed to, well, not all of them, like for instance, exec is not a translator, I think. No, it is. Okay, oath is not a translator, prot is not a translator. So more correct term would be these are all HURD servers. Some of them translators, most of them. Yeah, they are conventionally placed in /HURD, run from there. But this is just binaries. Whereas /servers, these are, well, this is in a way like /run. /run is a directory where various daemons, they create pit files and log files, but also sockets, like init control here, or run log, or xclone slicing is the same thing. Debug, who can debug system bus socket. This is a socket you can tell by the color. Basically, under /run, various daemons on Unix, it's not here specific, they create sockets that let you communicate with them. And under /servers, various HURD servers, they put basically their ports exported as files that let you communicate with them. So you can see, for instance, servers crash queue, for instance. This is an instance of the crash server. It will kill your task when you crash. Or, and of course, dumping core files and all of that stuff, that's all implemented in userland in the crash server. And there are 3 modes to it. You can either dump your core, or it can kill your task without dumping core, or it can suspend your task and let you debug it. I mean, it doesn't implement the debugger, it just suspends the task, so you can then attach GDB on your own, which is really useful. Something crashes, it doesn't dump core, it's a live process, you can connect to it and inspect it. And servers exec is exec server, and servers socket. This is how, if you comment this, you can see that these are just symbolic links to the numeric. This is where these socket servers store their files. This is how you contact a socket server. So to create like a pipe or a local Unix socket, you'd open servers socket 1 and then call something like create. So again, first servers is basically like a name directory where you can find places to contact running servers, or thanks to static translator records, they don't even have to be running. They will be auto-started if you try to open them. And /HURD is where the binaries live. You can see this with spatial trends. Spatial trends servers sect 1, and say HURD/pf local. So this is the binary, and this is the socket, so the file that you can use to contact it. And this is what glibc does when it wants to create a pipe or something. So you have to create these 2 nodes, for example, and for startup inside servers, but not much else for our root file system. but we are going to have to install all of these binaries. So let's do that now. This would be a copy from source, build, T2FS, T2FS static, control root FS, HURD. And then we need exec. We're going to need prods and o's and startup. Yeah, I didn't have anything else. At that time, you could also include copy pf local to get pipes, but maybe we don't need pipes for now. We don't need a bunch of libraries. Okay, so let's do this. Lib cso, obviously. Lib ld edge portal, lib m. I'm not sure how useful that is, but let's copy it over anyway. And by the way, you can see it here. Okay, let me copy it over first. Lib. But in here we have basically back user that I've been talking about. We should also have here it is libmvec. Libmvec is a like vector version of libm. I believe the transformation is done by GCT automatically, but I don't remember the details. What's important is this this exists on, I think, on x86-64 and on AR64. And I didn't have to do anything special to like enable it on AR64 GNU. It's just generic, it doesn't depend on the kernel, apparently. And when I made the AR64 GNU port of libc, it just appeared and built as a HURD. How cool is that? Right, let's also install libc. We obviously need Mac user and HURD users. Let's get those two. Mac user, so lib HURD user, lib HURD user. So first lib. And then we're going to need a bunch of, those were libraries from glibc, or libc, obviously. Libc, so first lib. And then let's install a bunch of libraries from the HURD. Source, HURD build, starting from lib should be in libc. And then what is it? Lib IO help should be there. Yeah. Lib hash is a good idea. There's also lib HURD bug other for some reason, which just contains a single symbol describing where to send bug reports, which is kind of ridiculous for a shared library. That's not what shared libraries are for, but sure. Okay, lib HURD slab, I think there was. Huh? What for this? Okay, that's enough for now. So next, we're gonna have to install libio help. libfs help. And then let's do lib ports and lib metafs. Little fast as well, especially since you're going to use it for our little translator. Is there anything else that I'm forgetting? Lib store. Well, you could install libdiscfs and whatever, but our xtfs is actually static, so we're not gonna have it. We don't have to install a second copy. Libbpf shouldn't be needed. Discfs no, fshelf this is fine, this is fine. Netfs yes, libpager, I forgot libpager, of course. Yeah, let's install libpager. Also, in a second thought, maybe nothing there uses it other than, again, xtfs, which should have its own statically linked copy. But still, let's install it just to be sure. Yeah, the rest should be there. And then we must, well, we could place a real console run binary there. But we're not going to do that since we don't have much of a console really. What we're going to do is write our own simple script that gets installed as console run. Let's call it fake console run. C stdio. And we're gonna use this little trick. Well, okay, here's the thing. We cannot really write to the console. Since there is none, you can do like open, what's called device open console. Yeah, indeed, it would be better to write a bash script. I didn't. In fact, the real proper way to do this is to, like, once you do make install, to install these all to my directory. And the real proper way to do this is to use a distribution which takes the source code and builds it and does packages, and then you can install a package. And as you all might have heard, I do have a little distribution of my own that I should, first of all, bring up to date, and second, make a version of it for AH64 GNU. I just haven't gotten around to doing that. So that's why I've done things manually now. Hopefully you should all also see that there is no magic here. I'm just copying over a bunch of files. So what I was trying to say is that you can open the Mac console device and you can write to it. The issue is it won't show up on our actual screen because I haven't implemented that on the Mac side. And that's actually true of the state of the AR64 port of the Mac in general. Very many things are missing. Many core things are there, so you can like create tasks and run them, and IPC works and stuff. But everything that comes to devices, there are practically no drivers. Hardware support is not quite there. So the thing that yeah, let's put it this way. If you want to help HURD on AR64 progress further, please grab your nearest AR64 board if you have one. If you don't, grab QEMU, build my branch, load it up, see what works and what doesn't. Most likely something fails. Write drivers, test things, submit fixes. I don't actually hack on this as of lately. And I certainly don't have access to whatever board you guys all have. So please, yeah, this is gonna be like a per board thingy. You can't write a single driver for everything because all the systems are different. So whichever board you care about, please help get it supported. Basically implement the drivers for in the Mac. You can ask me for, yeah, you can find me wherever, I guess email, or I should get back on IRC. ask me questions about Mac and how to write drivers. Not that I know myself. You can ask me how to build Mac for x64 for one thing. Yeah, you're gonna have to write the drivers. So yeah, what I was saying is that while you can open the Mac console device and write things to it, it won't actually show up on the screen because I haven't implemented that. What you can do, as of now, is use the Mac print debugging syscall. This one does write to the Mac to the real console, which is going to be a serial port. And we want to print and not just print. To work around that, what we're going to do is we're going to make like a print buffer of some size, and we're going to have like a macro as Mac print format, and then something. It's going to be macro that will. It's going to be nice. It's going to print to the buffer whatever you pass, and then it's gonna call Mac print on that buffer like that. Let's so that I want to receive ARM boards, also that would be interesting. I'm really not much of a hardware developer at all, as you may have heard. I really have a hard time basically with everything low level. I'm super surprised that I could do the sport at all. I didn't think I could do something like that. It's like a superpower actually. I just discovered this in me. Like who knew I could do this, right? But that still doesn't make me like the person to write drivers, which is evident that I couldn't. I'd rather ask you all to try to write drivers for whatever devices and ports that you have. I'd rather help you get my port running on your board than you send your board to me and expect me to write a driver, because that's not my thing. I'm more of a systems coordination, systems design, architecture person. So yeah, I kind of understand how the HURD fits together. I'm not good at writing low-level driver code. That being said, if you want to send a part to me, that would be pretty cool. Yeah, Raspberry Pi, whatever you think of the company, nobody's really happy with them right now, but it is like probably the number 2 target for the HURD and AR64. It's popular. Number 1 is the word machine in QEMU.
Sweet. That was a yes to accepting ARM boards from us, or maybe not.
I mean, yes, but rather than sending them to me, please consider writing drivers for them yourself. It's not really HURD specific. Like it's just a driver. You don't have to be a HURD expert. You have to be a driver expert, and I'm not the latter.
What is there a particular ARM board you're working with?
I don't actually have a physical ARM board as of now. I used to have a Raspberry Pi at previous day job. I do have an old phone that currently runs post-market OS. I'm not really gonna run HURD on it. Yes, I don't have a physical board as of now, which is why I had to. Yeah, but basically the part that I have developed, it ran in Camel. It didn't run on a physical board that somebody had. Somebody on IRC was kind enough to try my branch on his physical board, and it didn't work. And I had to do a lot of back and forth where I guided him in debugging it, and we fixed a bunch of bugs, and we got it to work much better on a physical board. So yeah, I don't have one. It would be cool to have one, but please don't expect me to write any drivers to get your board supported. Please do it yourself with my guidance on the Mac side.
Gotcha.
Okay. All right. We have pressure here. We do. We shouldn't.
Something that could be interesting could, though, to have some kind of location where we can note a name or maybe point to someone that is involved for a certain platform, for instance, for a certain board, because there's not that much of us, and probably we don't want to duplicate the effort. Maybe I don't know, or even to share tips.
You'd wanna like coordinate it instead, so that if two people have the same board, they could like share their work in a single branch.
Exactly. They really have to know that the contact for that other person.
Yeah. So if you look at like Post-Market OS, which is the distro that I'm using on my phone is OnePlus 6T, I believe. They have this wiki. Click. They have like this users who own this device. And you can in fact like click on any user, and it has like a list of devices that they have. Maybe we could have a simplified version of this in the wiki. I know Josh likes to edit the wiki, so we could, like if we could all list which boards we have, we could have a page and register ourselves there.
Okay, so it would be in the HURD wiki or something better? I don't know.
What do you mean?
Well, yeah, we'll figure out. No problem. It's a detail. First, we have to start doing stuff.
Right, so what I wanted to do here was this declaration. What? I think it wants me to add, include Mac age. It worked, seems to have at least. And let's, we're gonna have to create root of path libexec run systems, and we have to make it executable. It can be just a fake file, doesn't have to actually do anything useful, but has to exist, otherwise startup won't like it. Here, both were copies of the same file. They don't have to be. So I believe this should be enough to actually try to boot something. Let's see. I also have fast.ex2. Let's similarly move that away. Let's make a new one. How large was the old one? This large. Button can decipher this. It doesn't say it either. Let's try to use DU, although that's not the same thing. This has 34 megabytes. So let's try 36, I guess. Truncate rootofpath.txt to 35M. Make a path if C2 doesn't that exist, yeah, it does, C2 or HURD to enable compatibility on this new file system, and we should be able to mount it now. Root pass ex2 and mnt, and it wants my password because it's Linux and doesn't do unprivileged mounts. Great. So now we have a fresh new file system in this file. This is mounted on mnt.
So you are going to use the extended attributes then for that, since you're mounting on Linux, right?
I'm not gonna have any static translator records for now. Although maybe I should. But for now, all of this is just plain files.
Oh, okay. Okay. So there's no need to set translator to auto
Yeah,
start.
so the shell can boot without any translator records in some shape, like it can boot to a shell. And then to boot to a more complete system, you're supposed to create all of those records. I went through that when creating my own little distro based on Alpine. You'd like install it from a package manager from Linux, and then you'd boot it to a shell, and then from there you'd reinstall a package, basically the HURD package, and that would, this time, since it's running on HURD, it would create all the static translator records, and then from there you would like boot a more complete system. But here we boot an even more minimal system. There's not going to be a shell which is going to run this, right? The thing is, this is just a regular Unix program, except that it uses macprint instead of quick printing to send it out. So go is to run a very simple Unix program for now. So let's get copy things over from rootfs to mnt, right? Like that. And let's see what we end up with. Yeah, that looks correct, doesn't it? A bunch of stuff in HURD, we have a bunch of stuff in lib, the two files in libexec, and the two static nodes for servers to listen. So let's unmount it. And now comes the fun part, which is trying to grab my Gmail for the exact incantation to invoke this. And if we fail to, we're gonna need to make one up, like I did the first time. But if we don't have some, we can reuse the one that we have. It's too fast, for instance. Yeah, that's no, that's not real. Okay. Guess we're gonna have to come up with one line on our own. So this was for let's see back to the Mac directory. This was for, let's check that it still works. It still does. This was for starting out module hello. Instead, we're gonna start. We're gonna start XT2FS. Actually, we didn't even have to copy it into the disk image since we're not gonna load it from the disk image. We're gonna load it right here, right from our host file system. So this would be HURD. It doesn't have completion. Like that. HURD build C2FS. C2FS static. its arguments are going to be HTTP path, host port. Actually, let's check exactly what it expects to get. It would be depth cross card, source card, lib disk path, and something like startup. I don't remember. Let's grab passport. No. Post brief. Yeah, that's right, but that's not it. It should start with ops. Yeah, ops d startup sounds good. Yeah, these are the ones. Host brief port, device master port. Let's do that. Host brief port, device master port, task date, task resume. You also have to add another task, a different address. I really doubt this is going to work because we have to pick addresses carefully, and I did. This, yeah, okay, this is wrong. So the path in this case not going to be passed to exec since it's dynamic executable, and Mac doesn't know how to basically how to load an executable loader, since it has no reason to know that. So the should path here is the dynamic linker as a binary. And then in here, let's say LD ARch64. So one HURD exec.
It'd be really cool if we didn't have quiet boot anymore, if we got server boot running.
I'm not sure if you want, like, it would be cool. It would certainly help a huge lot to like debug issues with this. Task resume. Okay, so this
it also probably make writing out massive long boot scripts like this. It'd probably make that a little easier, I imagine.
Oh, probably. This is particularly bad because you have to write it all on a QEMU command line. And I shouldn't have to.
What is your X2 server going to use as a device here? Because usually we provide a device name, and
what's going on here is I ask QEMU to load this image into the guest's memory, and QEMU has this kind of device that's called guest loader, which is not really a device at all. All it does is it loads an image into the memory, and it like leaves info about that image in the device tree, and that's why we want to use it. We want the info to end up in the device tree, so that Mac can pick it up. So it's not really a device; it's just a way to load the binary. And in real life, you shouldn't. Well, in real life, you wouldn't be using QEMU, right? You'd have your real device. You would be using something like U-boot, which is a bootloader for AR64 and lots of other architectures. That's the one that's commonly used on AR64. And you tell U-boot with U-boot specific commands to load these images into the memory and to leave the relevant info in the device tree. If you're not familiar with device tree, is basically the format that describes the both the devices and some basic system configuration to the operating system that you're booting. So this is basically how the bootloader communicates with the kernel that starts. Because unlike on what I understand is called PCs, on AR64 and on many other architectures, you cannot really introspect the system. You cannot live detect what hardware there is, such as what interrupt controller there is or where RAM is located. Not that you really can do this on x86. I think you can't quite do that either. So lots of software that just assumes that memory starts at just 0. So I've heard, or queries things via ACPI or in other ways. But the device tree is the popular format in basically everywhere except on x86. This is also what is support in Max AR64 port. Alright, so we have to pass this. It expects exec server task. Exec server task is the task. After it runs this, it shouldn't yet boot. Let's just see what the error is going to be. It's going to be that we cannot use that address since x2fs terminates on this address. So let's try to use that. Let's, I guess, round it up to page size. So let's put 4 here. Yes, like that. Yes, it's better. It starts first, and then something happens, and we don't know what it is. Presumably, it doesn't put. Maybe it does. We don't know, but okay. Let's see here. Now we get to debugging, and this is actually exactly what Joshua has been talking about, right? It started like Mark started the first task, and we don't know what happened next. It didn't boot. We don't know exactly what went wrong.
Did you see that I actually added the server boot RFC request for comments document
Yeah,
to the HURD wiki?
I can't exactly say that I'm quite happy about you calling it that, but whatever.
I know you didn't think it was ready yet, but like it's just been sitting somewhere, and I wanted people to be able to read it.
Yeah, that makes sense. So let me try to debug this real quick. If I do in the progress, good. If we don't, then we'll end the stream there because this could take a long time, and I don't want to spend like several hours in the stream just trying to debug the boot. Okay, let's do this single file build. Oh god, that's that. Start, you load, you connect, and a single file which is built gnomag.elf offset by I don't remember, let's step in just offset by this build gnomag.elf offset by this, and we'll break on pmap bootstrap and up to continue up to there, and then we do this, right? Step all through this stuff, and then we're about to jump to a different address, which is right here. So we're gonna do single file, and then we need to add a bunch of F's here. namely 4 of them. And then there should be 1, 2, 3, 4 zeros. Like this. Yeah, great. So we might now break on task create and task terminate and also an exception. Let's see what happens. And also let's break on device write. And device write in band. Yeah. And
sounds like you already went there before.
Okay, so see, some task is trying to terminate for some reason, and the task that is being terminated is HTTPS. And actually, we can. This is really cool. This is something that I wanted to show off. I have all the right dwarf metadata for restoring saved register state wired up in the AR64 port, which means that GDB here, it can see through both through syscalls and various exceptions and through interrupts. So I can get a backtrace from the kernel into userland. And if I add symbols here, let me do that. That would be build HTTPS static. I can see backtrace through the userland, through a syscall into the kernel with all the register state, with all the local variables fully present. And the actual error application, it's very simple in fact in this case. It just says that we haven't specified a store for HTTPS to open, which is fair because we haven't indeed. By the way, yeah, this is this is an actual HTTPS built for AR64, running on an AR64 new Mac. So yeah, maybe it works glad. Let me just disassemble things for you somewhere, like in main here, for instance. HTTP assembly, yay! Proves that it's not 64.
Sergey, did you ever take a look at, I think it was Flavio Cruz. I think he posted some new ways to instrument the kernel. It was like a request for comments
I
email.
think Luca posted something like that. Maybe you think of a different thing, but Luca had a web branch that did add some tracing to the kernel, and I didn't quite look into it. I didn't quite understand why he wanted that, but maybe it could be interesting. It would definitely be nice to get something like dtrace that Solaris had, and then whatever the modern Linux thing is, BPF trace, I believe, which is really cute. Did you ever use BPF trace on Linux? Let me just still some examples here. I do have BPF trace installed, don't I? I do, yeah. Yeah, like this. This is you don't have to build a special build of your kernel or anything. This is just you just run this with sudo, and you get to see all of the files being opened by any process on the system. Let's say like this. You get to see nothing because nothing get open. Cool. Okay, obviously it doesn't work, but it would. Anything else? Yeah, see? So you did some tracing on my live system. Dtrace wasn't from OpenBSD. Dtrace was from the Solaris team at Sun. and then they ported it to various BSDs, including macOS 10. You can watch a bunch of talks from, I forgot his name, but this really cool guy who's even talked on all cool things in Solaris, and it was really fun. Brian Cantrell his name. Yeah, yes, this is I just ran some instrumentation on my live system as I'm streaming this. I don't run any special kernel build. This just runs on just on your typical usual Linux without anything special. You can trace, well, I mean, stuff are not very, maybe these days this is just called OpenApp or something. Why didn't I get trace? Yeah, see, this is it. This is live trace of every time any process opens any file on my system. Most of my terminal trying to understand whether or not I have an S6 section, as you can see. But this is live. This is instrumentation in a kernel. You'd be terrified to know what it does. It's like rewrites the kernel, like it patches the kernel at runtime. The specific function that I ask it to trace, sys enter open to like add this implementation to, yeah, Solaris. That's what I said. Wasn't Open Solaris either. Open Solaris was, again, Brian Cantrell has a real good talk about this. Open Solaris was a project to publish parts of, I believe, most of Solaris source code. No, it was never a BSD. It got ported to the BSDs. He wanted it to get ported everywhere. In fact, it was said to be very portable because it has to run in a context where it cannot really access much. So it cannot use much of the operating system's kernel's internal facilities, which makes it really hard to write, to implement, but also helps portability because it cannot much. I don't think it was ported to Linux. Maybe somebody did, but in any case, Linux has its own thing with this BPF trace thing. But yeah, you see, I didn't have to like disable any protection or run any like special kernel build. BPF trace works on my kernel here live without any, I didn't have to enable anything. It just does. This is super cool. If you could have something like this, like that, for Mac, for the HURD, that would be cool. Although I would expect it to be based on RPC trace and not on like modified Mac. I would expect it to be a tool that basically injects itself into every process in the system and then like steals all of their ports, applies to the tracing versions. I did, in fact, several years ago, I did implement into RPC trace functionality for attaching to an existing process, like strace does. It never made it upstream, so you cannot do this with RPC trace today, and those my patches are probably lost. I would have to re-implement it again, but it did work. It was really cool. You had like a live process, and you'd attach to it. And what RPC trace did was it would suspend the process, and it would inspect each port it had, and it would replace each and every port with a proxy version, and then insert back the proxy versions and arrange things so that the process couldn't even tell that anything would change. The process, it looked like the same ports were available under the same names with the same properties, like send count, whatever. It was fully transparent. And then it could disconnect it and it would do the same thing in reverse. Like it would look up which proxy port that it had and then replace it with real versions. It wasn't like 100% transparent. You could sometimes see like your calls returning your inter unexpectedly or something like that. But it was like 99% transparent to the process being traced. So if you had a whole system tracing solution like BPF tracing Linux or dtrace on Solaris and BSDs, I would expect it to be based on RPC trace rather than modifying MAC. But maybe we should look into that proposal of Lucas again. Yeah, so what I was saying here is we obviously have XTFS starting and exiting because it doesn't find any store. We indeed haven't told it what to load, where to find the actual file system image. So what we should do here is pass a third image, which is going to contain our actual file system image that we prepared earlier. And for that, we're going to have to use the RAM disk. The RAM disk is a patch that is also available at Debian's. They use it for the Debian installer, I believe. And I may have a much better version of the same, a different approach based on VM objects rather than a Mac device that I somewhat implemented, but I don't know if it works. So let's use RAM disk. But to use RAM disk, we have to ensure that we have the patch applied, and it looks like we do. Cool. So then we can use RAM disk. Let's do that. Device, ingest loader, kernel, and this should specify the file system image. And this is going to be protofs.txt2 that we prepared earlier. Bootargs something like protofs, whatever. And this should say yes, like protofs device equals RAM disk create. And then among ext2fs args, we should put like T device, which is the default, I believe, but let's put it explicitly. And then like this, protofs device. So if you're lucky, I'm not going to be lucky because for one thing we have to specify the size here. I mean the other. Let's specify the same thing and get an error and adjust it then. Yes, so the first free address here is this, which you may round up a little bit to get this. Okay, so looks like okay, this didn't work at all. We didn't get the podcast device didn't get set.
This should be with braces, right? The rootfs device, and not parentheses.
Yeah, right. I think this should be braces. Thank you. So parents are for basically executable commands, and braces are for substitution. Okay, so it did get set in this time. And again, we don't know what went wrong, but apparently something did. I love the current boot process. Did this? Oh no, we don't. But we can fill it from here, so let's try that. Did we add S? Didn't it? Oh, come on. Hate it. Okay, let's kill this. That's basically how you develop things, right? Yeah. Run it thousands of times, and you wrong. Okay, single file build gnumark.elf, and offset is going to be basically this. Let's break again on task terminate, and on task create for that matter, and on exception, and on device write invent. And let's run it. Don't target kernel is running. XTFS must be started as a translator. Okay, this is really stupid. Why does it do that? That happens when it doesn't think that it is the root file system. It happens when it thinks that it started as a regular process, because of course the root file system doesn't get a bootstrap port either, because there is no parent translator, right? So the reason it does that, if you look at this, it expects to get multiple command line set. And if it doesn't, it thinks that it's not the root file system. So all you have to do to get past this is add and we could specify the real multiple command line. Yeah, actually, let's do because right now not. So that we have to remember what it's called. Kern bootstrap C should have the command. Yeah, it's called kernel command line, the variable. Like this. And once again, let's connect GDB immediately, because I don't expect it to go right first time. Single file. And break on a bunch of this. Break on device write invent. Device write invent in this case is basically HTTPS trying to write to the Mac console. I've not seen it in here because I haven't implemented the parts of the driver as I was saying, but you can see it in the debugger. Let's create, sure, and break an exception and run. And it says cursor bootstrap. Ignore this because it's only writing says it 4 bytes. That's broken. It says exec. It creates a task. Actually, let's break on task set name to see what is going to be renamed. It says startup. It gets set the name HURD startup. Create new task called HURD prods. It writes prods. Create new task called HURD os. And it writes os. And it writes the dot, the period. And it writes the line break. Gosh, it's so amazing. And we create a new task, and we call it console run, which is our first Unix process, and it should be our task. And fingers crossed, this is going to bring hello world to the actual console here that you can see. And it did. Oh my god. Okay, I've actually gotten here before, but like this means that I'm able now to like rebuild everything from scratch with the latest glibc, and like we've guessed like assembled this command line here. Well, you've seen me do it, and you've helped me do it. So now that we got this, let's kill Camo because we don't have a way to kill it, and let's alter our little file here again. What's it called? Take console run, I think. Let's do something else. we can fork mark print, okay? Mark print fork this, and let's also print our pid and our get. And if pid is not 0, let's wait for a child to exit. And we're going to have to recompile this like this. And that's not going to work because we forgot to include stdh and also syswait. What? Yeah, we're in the wrong directory for that. Now we have to mount MNT again and basically copy over everything from rootfs again and unmount it again to make Linux updated. And then let's step back into here and run QEMU again like this. Oh, actually, we should drop the S's unless we want to debug it. Yeah, so see, it printed hello world, forked, and this must be the parent because we got the child's speed, and its speed is 1 because this is the first like regular Unix process, not a special HURD server, and its speed is also 1. And then the child's fork returns 0, and its speed is 9, and its parent speed is 1. Like this is Unix fork working. So it's incredibly cool. Okay, now we might want to try to build our translator. Let's, yeah, I guess let's just do the full thing. Because why the hell not? It's for fun. Okay. What were we doing? We had this in temp. It was called CRFS. And it had a make file which said use cc. And it had this command, cc is this make. So what if instead specify cc as def crossroad h4 bin h64 not gcc, same make. And it has up to date because it doesn't understand that we've changed the compiler. Yeah, this doesn't find the proper libraries. So we haven't done make install. So let's do make install because why the hell not, right? And this too wants to have test dir equal to prefix. It seems to be doing things for whatever reason. Let's start with the change.
What's compiling right now?
It's the HURD, although I'm surprised that it does so much because it shouldn't, like it should only install things, not build anything. Okay, I don't understand why I decided to suddenly rebuild all these things, but whatever.
Have you heard of Guile config, Sergey?
Guile config? No, what's that?
I'll put a link in the chat but it's a way of specifying. It's an alternative for argp, but you use guile instead, basically.
Alternative to what? Because they didn't build at all. It didn't find this file. And so didn't do make installing mark, did you now? Then simply delete. Okay, that makes sense. Let them make install. So it should be now prefix include mark preg h, right? Mark h64. Prefix include mark h64 if reg h doesn't exist. Why doesn't it? Most importantly, why does this thing think that it needs it? How about we drop the HURD? Yeah, it really does work. Just set it in the file. Okay, so now Control D. Let's make it. What now? This pager.o. Okay, now it wants startup.d and also memopsh.d. Yeah. Wait, Trio has server replace that? That's really not supposed to happen. Yeah, that's just libmacdev. It's not gonna work. So what I should do here is I should like take this file and specify the dependencies explicitly instead of relying it to find it implicitly. So def assert h64 source HURD build libtriofs libtriofs so, and that's not enough. It also needs reports. And it also wants lib should be libc. Yeah, so it builds. So we've got our Caesar, which is now R64 version. Is it mounted? It's not, but whatever. Let's copy temp Caesar as Caesar onto like rootfs HURD Caesar, right, into the HURD directory. And let's write just some sort of a text file in libexec, for instance. Directory, I know. Let's call it hello world.txt. Hello world, like that. And let's do what you wanted me to do. And I'm gonna figure this out as I go because I have little idea how to. Hello world.txt translated, right? Let's call it CSR for Caesar. And we're gonna like set the attribute on that. So how does that work? Like the new translator, it must be that. New translator. Indeed, so HTTPS respects that. How do I set extended attributes? Any idea? Anybody? Set f-utter. Set x-utter 2. Or utter 1. I set xfs. Set f-utter. Extended attributes, right.
What's your question, Sergey? Were you asking us something?
Yeah, if anybody has an idea of how do I set these extended attributes from Linux, because I'm trying to set a static translator data here. Let's try set f-utter GNU.translator not like that, and GNU translator, and then the value. Any control characters can be encoded as a backslash followed by 3 digits, as it's called octal. So basically what we want to do here is HURD Caesar \000, I believe, and then the path to the original file, which is going to be libexec hello world.txt. And that didn't work. Right, because it wants the file. Like that. Operation not supported. What?
Yeah, because you're not in your image, I think. So you may be on XFS or something.
I'm on Btrfs indeed. I think that this only works. Right, okay.
Yeah, well, maybe you should copy in the file system and then
let's
do it.
do this on the image directly. So with copy things. Where my copy? Come on, to the copy this. And then we try to set this on the image directly. mnt libexec hello world.txt csr. Image name, that's better. Yay, set. What happens if I try to get it back? Get other D name. We can do -d to list all of them. That doesn't seem to exist. get F letter, indeed. D on that. It doesn't seem to be any. If I did N GNU translator, would that help? Yes, that worked somehow. Hopefully, this does mean that it like, picked up the 0. I'm not sure. Let's see if you pass in as like hex, would that be visible properly? So we get 2 consecutive zeros. This might just be. Let's also take this.
Yeah, there's 2F after it.
Does this match up? 2F, and then right here instead of 2F again. No, instead of 50 here. 72. Right. It seems to have generated the right thing, right? Hopefully. Okay, we've unmounted MNC, except we shouldn't have. We should do now is modify our little test program to open and read the file. And let's use the standard Unix/C stuff for this. The I already got included. So let's not fork, let's slip it. Let's go fopen. Reading this file. Already know that. If there's no, we don't even gonna, yeah, we're not gonna use any GNU specific stuff. So let's do the boring P error. Fail to open, return 1. And then let's read the byte. And we can't even use popen because we're not going to see that. So mac print failed to open /s z /m. It's going to be stir error of r node. Okay.
And doesn't the extended attribute have to contain also the path to the file itself?
What do you mean? First of all, I don't know. I really don't know much about extended attributes. But as far as I understand, you just set GNU translator to the translator record. No? Maybe I'm misunderstanding this. You tell me.
Oh yeah, well, I'm not sure I understand. Okay, well, please go on.
How to use fread? You pass it a buffer, and then 2 numbers which it multiplies, and then a file. So the buffer, let's make a buffer. And then size is going to be 1, and members is going to be, let's say, 5. And the file is going to be f, and this is going to return number of values that it read. And let's just dump that.
So are you writing a C program on the fly to change the extended attributes of a file?
Not to change attributes. This is a C program to just open the file and like read its contents and dump it to the console. And this is
it's a Sergey's cat implementation.
yeah. That's exactly a cat. I could password exactly cat here. The only difference being that it doesn't write to its std out, it writes using Mac print, which dumps to the Mac console using Mac print syscall. So you can't use the real cat. But note that other than this is a regular Unix program. It doesn't do anything Mac or HURD specific. It gets started as PID1, which is not super common, but happens. But yeah, it's a Unix program. It uses Unix things to access everything. The point here being that we do start enough of a Unix environment running, or enough of HURD running to provide a regular Unix environment to our PID1 program. Okay, so Mac print fred. What do we do next? If that was an error, I guess. If n is not 5. Yeah, whatever, let's just print the first few characters of our buffer. Let's do this. Super simple. Buffer 0, buffer 1, buffer 2, buffer 3. We can actually run this in the debugger. We don't even have to print it. Yeah. But what
There is still something that puzzles me, because you've set the attribute on the Caesar target file.
Yeah.
But then I don't see where the information about what the source file is going to be provided.
So the source file is just a regular text file, and then on here, this is the command line for the translator, and the command line includes.
Okay. It's parameter. Okay.
Yeah.
Okay. Yeah. Well, sorry.
Okay. What now? Still error. What do we do to get that? Page. Sure. Hopefully it's gonna work that way. I don't know. Okay, we built it. And I guess we have to mount things back to the mount, right? And let's copy it back. Not gonna copy everything. We're gonna copy this one piece. I'm gonna need sudo mnt libexec console run. Unmount cd2 mac run camel and pray, and didn't work. But why didn't it?
Well, the file system image changed size.
It's larger indeed. No, but these two now enters. What? We rebuilt X2FS and now it's larger. We don't even know. Okay, let's move things around, I guess.